myself, Sindhya University from CSE third year. So as a part of my machine learning and techniques laboratory, I have implemented the experiment number 10, which is Ensemble learning for random forest and AdaBoost. The main aim of the experiment is to implement the ensemble models to perform classification and to evaluate the performance of the model. First, looking into it, what is ensemble learning? Ensemble learning means combining multiple models to improve performance instead of relying on a single model. So there are two types of ensemble learning. One is bagging and other one is boosting. Bagging is a type of random. The example of bagging is random forest, and for the example of boosting would be AdaBoost. Looking into it, random forest is a bagging technique where the multiple decision trees are created in parallel. So this helps to classify the data points for the given dataset using multiple trees where each tree gives us the predictions. The final output would be the majority of the voting, and this would help in reducing the overfitting and the variance. Next, speaking about the next thing, which is AdaBoost. AdaBoost is a boosting technique where models are trained separately, unlike random forest, where the key points should focus on in AdaBoost is it focuses on mistakes of previous model, where the misclassification of points get more importance in the previous models. So this helps in pointing out the issues, and it combines weak learners into the strong model performance. We could simply tell it learns from the errors step by step. Looking at the experiment, first we are going to import all the necessary libraries, pandas, numpy, and for pre-processing we'll use label encoder and simple inputter. And for the model selection, we will be taking train, test, and split to divide the data for training, testing, and then ensemble random forest classifier, and the metrics we would look into our accuracy score, precision score, recall score, F1 score, and confusion matrix. Looking into the experiment step by step, first we are going to load the data set, which is iris slp.csv, and first we have print the first 5 rows of the data set. Next we are going to do the necessary pre-processing, which is nothing but handling the missing values, where we are going to take the mean range of the missing values and going to fill those using fill now. And for the next thing, we have used simple inputter function for handling the missing values. Instead of numpy library, we are taking a direct object mean from objects in the simple inputter and then printing the column. So here we got 0, 0, 0, all zeros, which means there are no missing values in the data set of the given derived columns. Next we are going to do Next, we are going to standardize the data using label encoder, and we are going to fit the transform to standardize the given data so that the range would not fall out of the given range. So once after the standardization is done, we are going to print it. So here we got the range of the DF species which we have implemented using the standardized function, which is fit transform. Next, we are going to choose the independent and dependent variables in a given data set. So for that, first we are going to take x and y columns, where x takes the independent variables and y is a dependent variable, which is species, as we have taken. And once after we have derived independent and dependent variables, we are going to split the data into training and testing, and we have printed the size accordingly for the training and testing of the dataset. Next, we are going to take the estimators and maximum depth as given from the question. They have asked us to take for 50 and 100, and maximum depth would be 2, 3, 4. So n estimators interface the number of trees, and maximum depth would infer the depth of each tree. So the depth of each tree would be 2, 3, and 4, and the estimators would be number of trees, which are 50 to 100, 50 in the range of 50 and 100. Next, we are going to create the random forest regression model for the parameters using a random forest classifier. So for n in the range of n estimators, so it starts iterating in n estimators from 50. So as we can see here, it is printing once after this thing. For each depth, it is going to print how much depth it takes for the model. Next, for the different parameters of the random forest, we are going to calculate the precision, accuracy score, and F1 score for the model. So first here we have created the model. We have deployed the n estimators and maximum depth d into the random forest classifier. So after every train and at every y train and x train, it is going to fit into the model and it is going to predict. This loop iterates from 50 to 100 and to the depth of 2, 3 and 4, which is 2 to 4 range. So each time this loop iterates, it goes from the tree goes to the depth of 2, 3 and then 4. So once after this, this is a output which have been predicted by a random forest classifier at the depth of 50 and maximum depth at the estimator of 50 and the depth of 2. This is the accuracy precision we would get. So lastly, we are displaying the confusion matrix for this. So where accuracy is overall the correct predictions, precision will detects the correct positive predictions from the derived implemented model. Next, recall tells us how many actual positives found from the model deployment, and F1 score balance the prediction and recall. So once after this, the confusion matrix shows us the correct and incorrect predictions from the deployed model, and it helps us analyze the model performance deeply. Now next, this would tell the overall performance of the random forest classifier. Next, looking into AdaBoost, we are going to import the dataset as before and then do the pre-processing techniques using simple imputer and label encoder for standardization of the function. For the we have initialized new variable df species and then fit the transform of the standardized data into the df species. So here we can say 0, 0, 0. Next, we are going to derive the independent and dependent variables. So independent variables would be x and dependent variables would be y, and we are going to print it accordingly to know what exactly and what is correct from the derived independent and dependent variables. Next, we are going to choose the parameters same as before. N estimators would be 50 and 100, and learning rate, here we would take the learning rate which is 0.01, 0.1 and 1.0. Whereas before in random forest classifier we have taken the maximum depth of the tree where it deals with the trees. Here we are going to check the error rate compared from the before predicted model to the model which we are going to predict now. So we have took 50, 100 and 0.01, 0.1 and 1.0. Now we are going to create the model of AdaBoost with defining parameters. And we are going to iterate here. Model is equals to AdaBoost classifier. So here we have declared the model and deployed the n estimators and learning rate. So at each iteration it checks for 50 and then 100. For learning rate 0.01, the accuracy would be this, and for the learning rate of 0.1 it would change to this. At the very next step, we are going to display the confusion matrix, where the confusion matrix would tell each model learn from the previous mistakes, as we can see here. The model, after fitting the model x train and y train, y predict is equals to model.predict, where predict is a predict function used to predict from the trained data using the x test data from the previous values to the predicted actual values. So the confusion matrix we got is 11009 for all the running rate which we have been classified. So this confusion matrix of each model learns from the previous mistakes in AdaBoost, whereas in random forest classifier it checks at the each and every depth and finds the correct and predicted output. And this AdaBoost focus increases on the wrongly classified points. unlike to random forest class 5. So, concluding from this experiment, we learned how ensemble methods improve model performance, whereas random forest works by combining multiple trees, while unlike AdaBoost improves by focusing on errors and by using metrics called learning rate. Both techniques provide better accuracy compared to single nodes. Thank you.